I am Jonathan. I am a staff machine learning engineer at Hinge, like Tristan just said. And I work on a team internally called AI Platform Core, and we'll talk a little bit more about that as I go on. But today, I'm going to be exploring the topic of machine learning model ownership in production. We'll discuss specifically what ownership means in this context, and also what it means as the various moving pieces that contribute to what I like to call a long tail of ongoing ownership overhead for any given model that you deploy to production. I'll be framing this discussion around my team's work at Hinge AI in building a generally available model serving platform to power all of our ML model use cases at Hinge over the course of this past year. By the end of this talk, I'm hoping that you all walk away with what I believe is a generalizable principles-first playbook for building out a model-serving infrastructure from scratch, one that can actually robustly solve the fundamentals of this entire gnarly problem while giving ample headroom for growth and expansion into the future. So with that, let's get right into it. In a map of what we'll be covering today, I'll give a quick introduction to Hinge for those of you that aren't on the dating scene right now. I'm going to talk about the AI department at Hinge and the role that AI plays within Hinge as part of its product roadmap. We'll go over the challenges associated with production model ownership to give us all a shared common understanding of the problem here. And then we'll move on to talk about how we chose to tackle this problem at Hinge. Well, here is where we'll introduce Hinge's model serving strategy, which I had the honor of helping to form and drive over the past year. And we'll talk about the primary focuses coming out of this strategy and how we use that as a framework for choosing which parts of the problem to focus on first. And then at long last, we'll get into the specifics of what we built as a result of this, and I'll give some thoughts about sort of how that's proven successful for us and how we see it growing moving forward. Backing up a bit, like Tristan just said, I'm a staff machine learning engineer, Hinge. I've been here for about the past year or so. My primary focuses have been on driving the model serving strategy, and that's going to be the focus of today's talk. So with that, let's talk about AI at Hinge. So again, brief overview of Hinge. Hinge is a global online dating platform. We are proudly owned by the Match Group, and we have some very good success on the market as late. We have 10 million monthly active users, and the product is one of the top 3 most downloaded apps in all of its target markets. In the meantime, Hinge AI is a 20-member organization within here. So we're a lot smaller than a lot of the AI orgs that you would see at the larger companies you can think of. But I sort of see this as one of our superpowers. This allows us to move very quickly, and as coming from a platform perspective, this also gives me the luxury and the benefit of being able to work really closely with my end users, which ultimately are my other teammates. We focus primarily on 3 product areas. The first one being dating outcomes. This you can essentially think of as the recommendations org. And then we also have trust and safety, which is tasked with ensuring that the platform is safe for all of its users and is responsible for driving back bad actors out. And then lastly, we have the growth team that is responsible for user acquisition and retention. Underlying all of this is my team, the platform team. I sort of think of it as a supporting bedrock. We do focus on 2 things. One, we focus on the gnarly infrastructure problems so that our MLEs can focus on what they do best. But at the same time, we also engage in ongoing dialogue with our MLEs to make sure to sort of like notice what the best practices are and then build tooling around them so that we can codify those and ensure that the system sort of helps people along the right path. Some recent deliveries from Hinge AI of late. The most recent one is a feature called Prompt Feedback. This just launched about a month or so ago. It is an LLM-powered feature that essentially you can think of it as the app coaching you in how you fill out your profile, so that, for example, if a user's response to a question like, for example, what's your favorite thing to eat for dinner, is kind of vague or ambiguous or not really going to drive a good conversation with folks, it'll like politely but encouragingly nudge them to expand the answer a little bit. At the same time, on the trust and safety side of things, we have a feature called Are You Sure? The goal here is essentially to stop harmful and potentially offensive messages before they are even sent and have a chance to do damage. At a high level, this is a fine-tuned Roberto model that we serve internally on our infrastructure via Rayserve. So Let's define the problem a little bit here. I've used this term of a long tail of ownership for a couple times now, but what am I actually referring to when I say this? So let's break this down a bit. Let's explore a hypothetical scenario. That's just any scenario. This doesn't actually have much to do with Hinge, but let's say you're on an ML team. You've been asked to deploy a model, develop a model. It doesn't really matter the model in this for the narrative's sake, but let's just say that's what you've been tasked to do. Your team goes heads down for a quarter. You develop your model. You identify all the features. You fine tune it. You've uploaded the weights to S3. Okay, cool. You ship it at the end of quarter, and everybody celebrates, or so you think, right? And you think. By then you think that your job is essentially done, but over the next quarter you find that your team needs to make these unexpected improvements to your deployment. Let's say that, for example, the next quarter, data science comes along and says that they want to collect all the inputs and outputs of your model for downstream analytics. Okay, sure. Well, your team's just gonna goes in, make some changes to the deployment, no harm. Now, product comes in and says they want to override it for specific input values. Okay, that's more work you need to do. Now, say your own team comes along and says, okay, now we need to actually improve this model. So now we need to build out A/B testing infrastructure to be able to serve multiple versions of this model at the same time. Okay, but now we're 3 quarters in. We thought this work was done. And this just keeps piling on for your team over and over, and you sort of realize, okay, production is not the end of the story for you. It's actually only the very beginning of things here. And then because you're an ML team in a functioning organization, your job is not to just own one model for the rest of your life. You have to do this multiple times over. So now this problem kind of compounds on itself over and over again. But now with the extra luxury of all the past work that you deployed kind of bogging you down. So now instead of taking 1 quarter, the next model takes, say, 2 quarters, and then the next 3 quarters. If left unchecked, this basically snowballs into a problem of reduction in velocity, where it now takes you longer and longer to ship out each new model. Yes, like I said, ultimately what this proves is that when you ship something to production, this is ultimately only the beginning of the rest of your model's life in a lot of ways. So that is what I'm referring to when I say the long tail of model ownership. Now let's back up a little bit, bringing this back to Hinge specifically. Let's rewind to mid-2024. Hinge AI is in the midst of explosive growth. We started, just to put some numbers to it, the beginning of 2024, we started at around 8 or 9 people. I can't remember. But anyways, at the end of 2024, we had tripled in size to about 24 people. So as you can imagine, this created a lot of growing pains for the organization. I think one of the most foremost ones was the fact that every product AI team had its own sort of bespoke infrastructure and bespoke way of deploying things to production. And in a lot of ways, actually, 3 different definitions of what production actually means. So besides the fact that this was really confusing as an organization to think about, it also meant that there was no opportunity for creating leverage across the entire organization. And by that, I mean, like, basically, if you take something that one team develops and you say, okay, this is actually really useful, can we expand this out for the rest of the teams to use? This was actually so difficult that it basically was not even worth pursuing. And concretely, this really had tangible consequences, right? The most obvious one is this top-level metric that we measure called time to production for new models, and that sat at about 70 days. That is 70 business days. This is a very long time to take for a model to go to production. So as it hopefully goes without saying that this represents a really critical bottleneck for the organization. So with that, AI Platform Core was formed with the very express and very simple mission of driving that number down, preferably as far as it can go. I was hired as engineer number 3 for this team, and I was given a really, really explicit mandate when I joined. Give us a model serving platform, Jonathan. I don't care how you do it, just do it. But what does that mean? What does that mean exactly? Like, model serving, if honestly, in my experience, also if you ask 5 different ML engineers what model serving really means, you'll probably get 3 to 3.5 different answers. So with that, we kind of realized there are a lot of different directions that this could go. So there are a lot of things that you can build that kind of sit under this nebulous cloud of model serving. And this, for a team of, at the time, 3 people, this really created a really big risk for us in terms of diffusing our focus. So with that, we decided we need a strategy. And what I really mean by that is we needed to take a really kind of like principles first look at what the problem is we're trying to solve here. And we can sort of think of this as in 3 phases. One, we actually need to define the problem, and like in terms of specifically what's going on at Hinge and what the priorities are at Hinge, rather than take what is commonly considered a solved problem in industry and try to shoehorn it into Hinge. So with that, let's talk about some of the diagnoses that my team realized when we were building out model serving infrastructure for Hinge. So I think starting from the beginning, we realized to solve the problem of people not really talking about the same thing, we decided very simply that model serving at a very high level is anytime your model's outputs are used as part of her production system. So with that it's a very simple definition, but it actually creates some interesting implications for how your infrastructure is run. For one, with that, we identify 3 modes of model serving. I think this is a little bit, atypical in the industry. Typically, when people refer to model serving, they're referring to, take the model, put it up behind a REST API server, or, gRPC if you're feeling fancy. But we decided that was actually only one of the ways, and appropriately, we call that online serving. But at the same time, we also identify batch inference as well as asynchronous inference, where you deploy the model as part of a streaming pipeline that reads and writes from Kafka, for example, as part of this same umbrella. We decided as a team it was really crucial to support all 3 of these modes equally at the same time, rather than trying to overinvest in one approach at the expense of all the others. This, beyond just like a team charter level, this also holds our architecture accountable, because it actually, by introducing this restriction on ourselves, it made it very easy for us to use that to inform the architectural decisions that we made, which I'll get to later in this talk as well. So with all those 3 modes being identified, the next thing we wanted to do is figure out is how do we want to carry out this development project. It'll take multiple quarters. How do we make sure that the team stays focused on the right problems? With that, we decided on 3 sort of norms for how we develop this platform. The first one being, we placed a very heavy emphasis on minimizing the contextual burden to ML engineers at Hinge. No one's job is to manage the laundry list of 20 million different infrastructural paradigms, every Kubernetes, every Docker, every fast API, every Pydantic, every Ray serve, every Ray, every kube-ray. No MLE actually considers it their job to juggle all these things. So we decided that this was a good opportunity for the platform team to come in and provide a very streamlined approach to these things and manage that complexity on users' behalf. On that note, however, we also focus on what I think of as enablement over flexibility. A lot of platform teams that I've seen over the years kind of take this approach of, okay, we will take a very laissez-faire approach to this. We will let you use our infrastructure any way that you want to and support any compute load that you want. Ultimately, because our team was so early stage, we decided it was important to focus on providing a single solution that works 100% of the time for all these use cases, rather than risking throwing several half-baked ones out over the wall that maybe feature incomplete in some way. The third thing is co-developing with our MLEs, basically. So this is where the luxury of working in a smaller org like this really comes into play. This gives our platform team the real luxury of just walking over to, for example, trust and safety and say, hey, do you want to try this new model serving approach out and see what happens? And we took really liberal advantage of this as we were building things out here, and I think it's proven out really well for us ultimately. So with all of that, we finally come to the real meat of this, which is, okay, now we've decided how we want to build this infrastructure, so what are we going to focus on? And this gets back at this gets back at what I was talking about earlier, where model serving in the industry right now it's a very established problem. There are many different facets of this. We wanted to figure out which of those were the most important for us to focus on at Hinge at this current time. So with that, we decided on 3 strategic focuses for our model serving infrastructure in its initial state. First, we decided to prioritize aligning on a single unified model registry, which would then allow MLEs to register their model once, manage it in a single place, and then most critically, deploy it across all 3 model serving modalities that I mentioned earlier. The second one is investing really heavily in observability. And I mean this not in terms of stuff like API latency, P99 errors and stuff like that, but really like understanding, okay, here's how this model performs. It performs in production. Does it line up with what we saw in offline experimentation, for example? Does that point to, are there any hidden problems that arise from, for example, feature drift or model degradation over time? The third one is we really invested in enabling our ML teams to iterate on their model over time. Like I said over and over again, production is really just the beginning of the rest of your model's life. So we wanted to make it really easy and provide solutions for the inevitable case where you need to improve your model over time in response to, for example, changes in the user population. So now, with all that being said, we get to the real heart of things here, which is what did my team actually build as a result of this, right? So like I said earlier, the first one was a unified model registry based on MLflow. And the choice of MLflow itself is not particularly revolutionary at this point. There's a reason it is considered a de facto open source standard, but what are the implications to this? Like I mentioned before, our real priority here was supporting all 3 model serving modalities at once without one taking bias over the other. And we realized that MLflow structurally was very well suited to do this. And what I mean by that is, unlike other products on the market, for example, that are large, might be largely management wrappers over S3 buckets, for example, like that. MLflow is based around registering your model not just as the weights itself, but also the inference logic to an extent. I think it's like they have this notion of flavors and a Python model class that gets pickled up alongside the model weights. So this actually means that every registered model version in MLflow is itself a self-contained deployable unit. And this creates a really valuable user flow for us where our ML engineers can register their model once and then deploy it to any of the three places that they might want to. Like, for example, let's talk about the online serving use case. From our MLflow model registry, these models can be deployed to our internally developed RayServe architecture that we deploy via KubeRay on top of EKS in AWS. The nice thing about this is that this then also allows us to in a very compute efficient way, kind of hot swap out the versions as needed based off of, for example, like header IDs in the request body. So this itself gives a really solid foundation for example, A/B testing or blue-green deployments for your models over time. Once switching over to the batch and the async part, this is where MLflow kind of natively really gives a lot of benefits. More specifically, MLflow has native Spark integration, which then means that any model that you pull down from MLflow can be used as a Spark UDF. That's a user-defined function. But what this really means is that you can pull down the model and then use it directly as part of the Spark SQL query itself, which becomes very valuable for our engineers when they, for example, bundle that query up as part of a scheduled run, for example. This, on top of being able to kind of like deploy this model into 3 different places, this also has another implication in that this allows our ML teams to transition from one model serving mode to the other based off of their evolving needs. Like one one use case we sort of think of is starting off. You might just decide to deploy your model in batch, and you use this to sort of iterate and refine your model over time. You don't really sort of know how it would perform on production data, so you decide to start in this risk-free kind of way. And then as you gain more confidence in your model and its performance and accuracy, then you might graduate to, for example, streaming, async serving, or even online, depending on how your back-end engineer collaborators might need this information. The second pillar of our platform is an internal library that I call the Hinge AI Runtime, otherwise known as HARE. It is basically, at a high level, this provides standardized solutions for online model serving at Hinge. Like I said, I think of the platform team internally as sort of like the not the arbiter necessarily, but like we're the record keepers of what best practices are. So I really think of HARE as the embodiment of that principle. We observe how our internal teams sort of interact with, for example, Ray-serve or Spark streaming, and then we look at repeated things repeated challenges that all these ML engineers face, and we codify them into here, and we provide very stock solutions for that. So some things that we've built into HARE as over the last couple of quarters. One is, like I mentioned before, integration with MLflow. So this covers not just like the foundational stuff like auto authentication as well as token refreshing, but also model multiplexing. So like I said before, in an online setting, you can use request IDs to like hot swap out the weights. So this all is done in a very compute efficient way, where for example, the weights for version 23 of your model will only be pulled down from the registry if and when a downstream service actually requests it. And then you can also configure the online server to, for example, just shut that down if it's not used for like a certain amount of time. This turns out to be very valuable for us internally. The second thing that we built into HARE was standardized SLIs. We found out, and for those of us that don't come from a SRE background, SLI stands for service level indicators, and these are we can use these. Essentially, you can think of these as the canonical metrics that determine the health and effectiveness of a service in production. In a lot of ways, we realize that an online serving model is essentially just a microservice dressed up in a nice layer. So we realized that it was very valuable to us, and as well as the backend services, to treat these online models as if they were microservices. So giving some examples of what HARE looks like in production. Like I said, HARE aims to empower our MLEs in very targeted ways, but more specifically, it gets out of the way as quickly as possible once it's done that job. I'm sure we've all used internally developed libraries that claim to accelerate things, but ultimately all you've done is introduce a layer in between your engineers and then the open source things that they actually are familiar with. So now they have to they're basically blocked on not just your team, but also this framework your team developed that is actually, despite your best intentions, probably less well documented than everything else in the open source market. So with that, HARE in the online serving context folds in really neatly into established APIs in Ray-serve. Like for example, HARE defines a serving app layer that I'm kind of speed running this, but serving app basically wraps a fast API layer that you can then shimmy directly into your Ray-serve deployment, and that acts as the REST API layer on top of your model. At the same time, building on the fast API foundation here, we baked a lot of the request metadata and the SLIs that I mentioned earlier into this. So those then get used under the hood by HARE itself for things such as prediction logging, which then, like I mentioned earlier, keeps track of every input and output that goes into your model, and then funnels that off into a Kafka topic that then eventually gets read into a Delta Lake table that we store inside of S3 that our MLEs can then query themselves to understand, okay, how is my model actually performing in production? Similarly, Hair, continuing on the 3 model serving modes thing, Hair is not just for online serving. We also use this to streamline common usage patterns across batch and ASIC serving use cases. I think for one example here is that a common use case at Hinge is to serialize the prediction serving model according to a protobuf schema before you send it down the wire on Kafka for backend consumers. This contains several kind of finicky steps along the way that not all ML engineers are like very familiar with. So we decided to streamline this for them with targeted APIs for example, schema lookup and serialization to basically look for the protobuf schema in a centralized location that we share with backend. At the same time, we also provide authentication mechanisms against both the schema registry as well as Kafka itself, with auth tokens that the platform team takes responsibility for, sort of like keeping up to date and shuffling out as the life cycle wears out. The third thing that we built is essentially a server chart. We, like I alluded to earlier, modern day cloud infrastructure is basically just like juggling several million APIs and frameworks at once. So we decided that MLEs this is all a distraction to MLEs, and this gave us a really good opportunity to streamline all this. So with that, the Hinge AI server chart, at a high level, a standardized Helm chart that we provide that streamlines the process for online model serving by encompassing all the problems that we kind of see with microservice and online model ownership. So that includes such things like ingress for networking, compute management, which we use. Like I said, we use Razor for online model serving, so KubeRay on top of EKS, job's done. At a low bit, KubeRay also gives us nice load balancing mechanisms along with this, which I talked about earlier in terms of multiplexing. At the same time, for SLIs and monitoring, we leverage Grafana operator, Prometheus, as well as FluentBit configs directly baked into the Helm chart that then shunt all model prediction logs that aren't the input outputs to Elasticsearch for MLEs to take advantage of. And that is basically, that's mechanically what we built at Hinge, right? But I think let's talk a little bit about what benefits this created for us. By providing all these very targeted solutions for the team across the board, we were able over the last couple of quarters to develop a soon-to-be generally available platform internally, and we believe that this is, with all these, we will be able to meaningfully drive down that sort of like ongoing ownership fixed cost for any model that a team wants to build. And by doing this and by trimming down that long tail and keeping it trimmed down, because it'll, like with all things in production, new things will keep popping up. So the platform team's responsibility from here on out is to sort of like keep track of how those fixed costs grow over time and continually work to whittle that away. And by doing so, we'll enable these teams to continue deploying and iterating on new models over time, and be faster about it, be more productive about it over time, and ultimately deliver on their own missions and help Hinge AI to succeed in what it does. That about wraps up my talk today. Thank you for joining me. I would not be doing my job if I did not point out that my team is very actively hiring right now. So if anyone's interested or thought that this was all really cool, I am happy to talk about that afterwards. Thanks for the time.